Okay, good evening everyone. Am I audible? Can you confirm? So today we are going to in the week fifth I have missed the tutorial session. Actually I was busy in some other meetings and presentation on last Monday. So that's why I have postponed my session to Sunday today. But from week sixth, all the session will be on Monday, uh, 5 to 7. So for today's session we will discuss the questions based on the week fifth lecture. So coming to the content of week 5 which is taught on NPTEL portal. So in this lecture it is taught about jet transform. In week 5th it is taught about jet transform and also inverse jet transform. So I have missed the week 5th on Monday. That's why I'm taking today. And from the next week all the lectures will be taken on Monday only. For week 6 tomorrow I will take the lecture. So this lecture is little delayed. Sorry for that, because I had some other meetings and presentations on last Monday, and after that Holi it was. So today we'll discuss about jet transform and we'll solve some of the important question based on the jet transform. So basically jet transform is the counterpart of Laplace transform in discrete time. So Laplace transform was for continuous time. So jet transform is for discrete time. And the frequency domain analysis of discrete time system allow us to represent any signal xn as a sum of exponential of the form zn. Like a signal xn can be represented as the sum of exponential in the form of z to the power n. So we'll see like for any discrete time signal, for any discrete time signal xn, its jet transform is given as. So here xn is the discrete time signal. That's why it is denoted as x and n instead of xt. So jet transform of xn will be written as xz, that is equal to summation, because in discrete time, in discrete domain, instead of integration we use summation. So summation n is equal to minus infinite to infinite xn into z to the power minus n. So we have to do this summation. After that, we'll get the Z transformer in the discrete time signal. So here Z is a complex variable. Like Z have real part and imaginary part, both as well. So Z is complex and it is given as Z is equal to R e to the power j omega. Okay. And here R is equal to distance from the origin in Z plane. Hmm. Like generally we use both, like in continuous time we use this omega mostly, and this omega is used in discrete time. Anyway, we can use both anywhere. Like in most of the book I have seen they are using in discrete also like this only. What frequency have units? No, like 1 by hertz. This sorry, 1 by second. हाँ हाँ. Yes, yes. For discrete frequency, like it's just in a magnitude and it's just a step by step. It is quantized. So here Z is a complex variable that is given as Re to the power j omega. So R is the distance from origin in Z plane, and it is just also the magnitude. So when we do the magnitude of Z, it will be R. So it is just a magnitude of Z. And also omega is an angle from positive real axis in Z plane. Omega is equal to angle from positive real axis in Z plane. I will see just in the lecture what notation they have used. That notation only we will use, else it will create confusion. So just wait for a second. In lecture also they have used this omega only for this discrete time. So we'll use this so that there will be no confusion. As I can see in lecture 25. So whenever we do the Z transform of xn, we can write it as xn is transformed as xz. And inverse Z transform of xz will be xn. So that also we will see after the Z transform. We will study about inverse Z transform. But first we will study about Z transform. So Z transform also. Sorry, I'm getting into the call. Just wait for me. So we were talking about the reason of convergence. So whenever we do, we also have to check the reason of convergence of what value the given Z transform converges. So we'll take some example and we will see for what value it converges. So like the Z transform is said to be converged if xn r to the power minus n is absolutely summable, like the formula of Z transform, that is xn. In this, we will see the magnitude of this and we will check if this value is less than infinite, means some value like finite value. So this means x of z is less than infinite. ROC consists of those value which for which the Z transform converges. So we have to check all the conditions. So we'll take some example and then we will see how to find the region of convergence of Z transform. And for for different signals have different region of convergence. So that we have to check. So we can take some simple example. Like let's suppose simply region of convergence is the value of the range of values for which Z transform converges. So let's suppose our example that is given xn is equal to an and unit step function that is un. So we have to find the z transform of xn. So for this we'll simply use the formula that is xz is equal to summation n is equal to minus infinite to infinite a to the power n un and we'll multiply z to the power minus n. So now we know that un is 0 when n is less than 0. So this summation will uh, trim up to from 0 to infinite only. So this will be an z to the power minus n. So we can write this as summation az inverse to the power n. Now the summation, such summation, like such infinite series summation converges like the value comes as a finite value only when az inverse is less than 1. So in this case, it will be magnitude of A is less than Z. So, so this is the reason of convergence. Because this the summation above can be calculated only when A Z inverse is less than 1. If it is greater than 1, then this is the infinite summation and the results will come as infinite. So now in this case, we know that when it is less than 1, it is 1 by 1 minus A. So like that will be Az inverse. So whenever the summation is like A plus AR plus AR square plus dot dot dot. So in this it happens the summation is the summation of all this is equal to A by 1 minus R. So here we'll use the same formula and we will get 1 by 1 minus AZ to the power minus 1. So when you calculate you will get, so for this we have got the Z transform. We'll write it below. The Z transform of this term will be Z by Z minus A and ROC will be magnitude of Z should be greater than A. Like this is our A is some pole. So in this case, the ROC will be, like let's suppose this is A. So let's draw a circle so that the magnitude of Z is greater than A. So this area is the ROC of this Z transform. So this was a simple example which was also done in the classroom, and we'll also see some of the other examples. So we'll take the first question of today's lecture, that is the ROC of Z transform of the discrete time sequence xn is equal to 1 by 3 to the power n un minus half to the power n u of minus n minus 1. So now we have to find the Z transform of this xn. sorry, in this question, we have to find the ROC of the jet transform of this. So there are four options in this. Option A is the magnitude of z is in between 1 by 3 to half. So we know the first term here is the right-handed signal, as for n less than 0, it is 0. So it is a right-hand signal. So for right-hand signal, the magnitude of z will be greater than a. So you can correlate here a to the power n u to the un as this. So a is here 1 by 3. So the magnitude of z is greater than 1 by 3. And also you can see here u minus n minus 1. This is a left-handed signal. So here for n is greater than or equal to 0, the value of u of minus n minus 1 equal to 0. It is a left-sided signal. So the ROC, so minus half to the power n u of minus n minus 1 is left-sided signal. So for ROC for this will be less than, like magnitude of z is less than half. Generally, we know when there is summation of two signal, then what we do, the combined ROC is intersection of both the ROC. So, like we know that see the magnitude of Z is greater than 1 by 3 and it should be less than half. So the ROC will be between my 1 by 3 to half. So option A is the correct option for this question. Also, we will see some of the like small example. Like some finite duration signal is given and we have to find the jet transform of that and comment on the ROC. So let's suppose if x1n is given as 1, 1 and 1, and this is in this question it is given this is a 0th index and this is a right-sided signal. So for this, by definition we know that x1 of z will be summation of, this is, if this is 0th index, then this is second index, and this is first. So for all other value, x1n is 0. So here the summation will be from n is equal to 0 to 2 x1n z to the power minus n. So you substitute all the value. When we substitute n is equal to 0, then it will be 1 into z to the power minus 0, that is 1, plus 1 into z inverse plus 1 into z to the 1 into z to the power minus 2. So the z transform will be 1 plus z inverse plus z to the power minus 2. Since here x1n is finite duration signal, hence ROC will be the entire z plane, as this is also taught in the week 5th lecture. But x1z becomes unbounded as z tends to 0, so ROC will not include z is equal to 0. So this will be like the ROC will be the entire Z plane and it will not include 0. So it will just radiate outwards excluding 0 on the entire Z plane. So we can take one more example. Yes, yes. No, no, it depends on the other poles and roots also. Like we can find here 1 by 1 plus z plus 1 by z square. So when you do this, we will get Z squared. So their pole at Z is equal to 0. That's why it does not include 0. Okay. Yes, sir. 0 to be included. No, it will not include the pole, like whatever is the pole, it will not include in the ROC. Okay. The poles are just the boundary and it is excluded from the ROC, region of ROC. So now we will take some two-sided signals. So here, let's suppose another signal x2n that is given as 1 comma 1 comma 1, and the zeroth index is given as here. So this is our first index and this is our minus 1, like in the negative side. So we'll again use the simple Z transform formula. So we will get summation. This time summation n will be from minus 1 to 1 x2n z to the power minus n. So here for n is equal to minus 1, it will be 1 into z to the power minus 1 plus 1 into z to the power 0, that is 1, plus 1 into z to the power 1. So it will be 1 by z plus 1 plus z. So here x3n is finite duration signal and hence ROC is also entire Z plane. But X3Z becomes unbounded when Z tends to 0 and Z tends to infinite. Like whenever we substitute Z tends to 0 or Z tends to infinite, it will become unbounded. Because this term, if you put Z is equal to 0, this term will become infinite. If you put Z is equal to infinite, then this term will become infinite. So for two-sided finite duration signal, the ROC is entire Z plane except here. In this case, Z is equal to 0 and Z is equal to infinite is not included in this in the ROC of this problem. So ROC is entire Z plane except excluding 0 and infinite. We have already seen the Z transform of A to the power n into un. Now we will see for this one, like left side of this, when xn is given as minus a to the power n u of minus n minus 1, then find xz. So for this question, we'll again use a simple formula of z transform. So xz is equal to summation of n is equal to minus infinite to infinite. It will be minus a to the power n u of minus n minus 1 into z to the power minus n. So in this we know that this u of n is from 0 it is 1. So when you do u of minus n minus 1, so it will become from minus 1 it will be 1 and for all other value it will be 0. So this is left-handed signal and also this summation will be from n is equal to minus infinite to minus 1 because after minus 1 the value of n is equal to minus 1 it is becoming 0 and we can write it as here it is minus a to the power of n z to the power of minus n. So this can be written as minus n is equal to minus infinite to minus 1. If we write here A inverse Z, then it will become minus n here because minus 1 into minus n is n and Z to the power minus n is coming. Now what we can do, we can substitute or assume n is equal to this minus n is equal to m. Okay. So now what will happen? our xz will be minus, and here you can see that m is equal to minus n. So if n is equal to minus infinite, then m is equal to infinite. Okay, and when n is equal to minus 1, then m is equal to 1. So this summation will be from infinite to 1, a inverse z to the power of m. So this will be minus, we can write it simply because this is summation, so we can just change the lower and upper limit. So now when you add it, xz will be minus of a inverse z plus a inverse z square, and this will go up to infinite. So this will become again, if we take minus a to the power minus 1 into z common, then it will become 1 plus a inverse z plus a inverse z square up to infinite, and this will become minus a to the power minus 1 z, and this will be simply 1 by 1 minus this term is the r, so this will be 1 minus a inverse z. So now we can just substitute here, and we can just simplify this. This will become minus of z by a divided by 1 minus z by a. This will become z by z minus a. Only thing is that the ROC will be less than, because see here, this a inverse z, this term should be less than 1. Then only this summation can be found by this formula. So here a inverse z should be less than 1. So in this case, the magnitude of z is less than magnitude of a. So here we can see that the ROC is inside. Like let's suppose this is our z is equal to a circle, then the ROC for this will be this inside. So the z transform of both this a to the power n un and this is same, but only thing is that the ROC in z plane is different. And just for simply I will write when xn is equal to del n, like impulse function, then the z transform of this is simply 1. We can calculate also, like we can do summation of del n z to the power minus n is equal to minus infinite to infinite. We know that in discrete time, if n is equal to 0, then del n is equal to 1. For all other value, it is 0. It will be 1 into z to the power minus 0, so that is equal to 1. So the z transform of this is 1. Now we'll take some other questions. So ROC will become the entire Z plane. Okay. So ROC of this is entire Z plane. So we'll take some example. This time we will just find the Z transform of some signal, which includes both the unit step in right hand side and left hand side. So in this signal, it is given that xn is equal to half to the power n un plus 2 by 3 to the power n u of minus n minus 1. So we have to find the Z transform of this. So we know that for Z transform of half to the power n un is simply Z by Z minus A. So that is, here A is half, so Z minus half, and the ROC will be magnitude of Z is greater than half. And now the second part is 2 by 3 to the power n u of minus n minus 1. So for this, the Z transform will be minus of, because here it should be minus, so it will be minus of Z by Z minus A, so Z minus 2 by 3, and here the ROC will be 2 by 3. So the common ROC will be from half to 2 by 3. So the common ROC will be the intersection of both the ROC, so that will become magnitude of Z is greater than half and less than 2 by 3. And xz is equal to Z by Z minus half minus 1 by, Z by Z minus 2 by 3. And the ROC is from half to 2 by 3. So these are the simple question which is also done in the classroom. And this Z transform also obeys the linearity property. So we'll see that. Yes, yes. We'll start from the first one, that is the linearity property of Z transform. We'll solve some question based on this also. So in this, if the Z transform of x1n is xz and the ROC is, let's suppose, R1, and another signal x2n have Z transform that is given as x2z and ROC is R2. So after that, the Z transform of alpha x1n plus beta x2n will be alpha of x1z plus beta of x2z, and the ROC will contain R1 intersection of R. And also we'll see the next one, that is time shifting property. So in this, if the Z transform of xn is given as xz, then the Z transform of x of n minus n naught is given as z to the power minus n naught into xz. So the proof is already done in the classroom, and we can simply prove it by using the formula of Z transform. So it's not a big deal. And also we'll see other properties like exponential multiplication, time reversal, and differentiation in Z domain. And after that, we'll solve few examples. This was the second one. The third one is exponential multiplication in like scaling in Z domain. So if xn have z transform as xz, then a to the power n into xn will be like the z transform of this will be x of z by a. So this is also like in this, if the ROC is equal to R, so here ROC will also scale with the magnitude of A here. So we can do the proof also, but I think these proofs are already done in the classroom. And we'll see the time reversal properties. So in this, if the z transform of xn is given as xz, then z transform of x of minus n is given as x of z inverse, that is equal to x of 1 by z. So thus we have to replace z by 1 by z. If the ROC of xn like xz is r, then the ROC of this x of 1 by z will be 1 by r. So we can prove this also simply using the formula of the transform. Now the next one, that is differentiation in, just I'm writing the summary of the lecture taught in the classroom. Z domain. So in this, if Z transform of xn is given as xz, then the Z transform of n into xn will be given as minus z into differentiation of xz with respect to z, and ROC will be same for this. Now we will see the convolution in time domain, and like if the signal x1 have z transform as x1z, and signal x2n, the z transform of this signal is x2z, then the convolution here will be given as the z transform of this is given as x1z into x2 of z, and the ROC will be the intersection of R1 and R2. Like let's suppose the ROC is here R1 and here the ROC is R2, then the ROC will be intersection of R1 and R2. So like just the multiplication in time domain, just in the frequency domain, sorry, the convolution in time domain will be just the multiplication in the frequency domain. So similarly, if let's suppose x1 convolution of x2 minus n is there, then we will find the z transform of both the signal and multiply it. So it will be x1z into this minus n is here, so it will be x2 1 by z. So these were the convolution properties. Now we can solve some of the question based on this.
Yes.
Yes,
Yeah. Another thing, like if multiplication and time domain in Z domain becomes convolution,
yes, yes.
okay, maybe that also we can mention, right? is the reverse.
Yes, yes. It is
Multiplication.
the reverse process, so here it is given by this.
Okay, okay, okay. And
Sorry for this. So, and also one of the very important, this property is used mostly in the gate question. So, like whenever most of the questions are coming on this only in control system also. Like if the jet transform of xn is xz, then we can also prove it. The jet transform of xn minus 1 will be z inverse into xz. So this is very, very important, and so on. Like whatever is the difference here, that here we will keep the power of z of that. So this is very important as with respect to the gate questions. Most of the question include such kind of terms to find the transfer function. So we can also solve some of the question based on that. And before that, we will take some one sinusoidal signal, and after that, we can take the jet transform of that. So here, before that, we will first see the causality and stability of this, and after that, we'll solve few examples. Then the theoretical part will be over for this week lecture. So like the jet transform for the LTI system, we will see like if xn is the input and yn is the output of the LTI system with the impulse response of hn, then here yn is equal to, like, let's suppose this is our system, input is xn and the impulse response is hn, and our output is yn, then yn is equal to xn convolution of hn. So we can write in the z transform domain that yz is equal to xz into hz, and the transfer function that is given as hz, that is equal to output function by input, that is yz by xz. So here hz is the transfer function, and it is just the ratio of z transform of the output to the z transfer of the input signal. So like now we will see when the input is impulse like del n, and when the input is a step response, then what will be the output? We'll see for both the case, and after that we will see for the stability. I'll take some question based on that. So let's take a question. Unit step response of the system described by difference equation yn plus y of n minus 1 equal to xn is. So we have to find the unit step response of the system that is described by the difference equation yn plus yn minus 1 equal to xn. So first we will take the Z transform of the above equation on both the sides. So taking Z transform on both the sides, we will get yz plus z inverse, because here it is n minus 1, yz is equal to xz. Now what we will do, we will take here yz common, we will get 1 plus z inverse equal to xz. So our transfer function, that is hz, is equal to yz by xz, that is equal to 1 by 1 plus z inverse. So this will be z by z plus 1. And we have to find the unit step response. So what we will do, we will substitute xn as un, and accordingly we will find the z transform of xn, and we will substitute in this equation. So yz is equal to z by z plus 1 into xz. Here it is given the unit step response. So xn will be unit step, that is un, and the xz of un is equal to 1 by 1 minus z inverse, that is also equal to like z by z minus a. So here a is 1 to the power n, so a is 1 only. So z by z minus a, so we will simply multiply it here. We will get yz is equal to z by z plus 1 into z by z minus 1. This is equal to z square by z square minus 1. So this was a simple question. Now we will see one more question.
Usually, whole stability and clarity with this. So,
Yeah, I will go to the
okay,
probability and stability just after one more example
okay,
that is based on impulse response. After that, the next topic will go on. So it is given sequence xn with z transform, that is given as xz is equal to z to the power 4 plus z squared minus 2z plus 2 minus 3 z to the power of minus 4 is applied as an input to a linear time invariant system with impulse response Hn is equal to 2 of del n minus 3. Here this is the impulse response function, that is del n is equal to 1 for n is equal to 0. It is 0 otherwise. So find find the output at n is equal to 4. So we have to find the output at n is equal to 4. Here the Z transform of xn is given, and also the input to this is given as the impulse response, that is hn is equal to 2 del of n minus 3. So we will see how to find. So we know that yz is equal to hz into xz, and here hn is given as 2 of del n minus 3. So hz is equal to 2 of z to the power of minus 3 coming from here, and yz is equal to, we will now multiply it, 2 to the power of 2 into z to the power minus 3 into z4 plus z squared minus 2z plus 2 minus 3z to the power of minus 4. So after that, let's take this z to the power of minus 3 inside. We will get 2 into z plus z inverse minus. So when we take the inverse transform of this, we will get yn is equal to taking inverse z transform. We will get yn is equal to 2 into, like here all this term we will take for all this term it is z to the power of minus 1, z to the power of minus 2, z to the power of minus 3, z to the power of minus 3. So here you can see it will be 2 of del n plus del of n minus 1 minus 2 of del of n minus 2. It is z to the power 1, so it will be n plus 1. I'm sorry for the mistake. And here again 2 of del of n minus 3 minus 3 of del of n minus 7. So this is our yn. Now in this question it is asking what is the value of yn at n is equal to 4. So at n is equal to 4, y4 equal to, when you substitute this, so there is no n minus 4 term. So at all other values it becomes 0. So the y4 will be 0. So this was the question. Now we will move on to the causality and the stability. So like for discrete time LTI system to be causal, the impulse response Hn is equal to 0 for all the value of n that is less than 0. So like Hn is equal to 0 for n is less than 0 for discrete time LTI system to be causal. And we'll see the stability and causality like by taking some example also. And for stability, like a discrete time LTI system is said to be stable if ROC includes the unit circle, like Z, magnitude of Z is equal to 1, and like all the poles of like transfer function Hz are within the unit circle. So a causal system to be unstable if and only if at least like one pole of Hz is outside the unit circle, or there are repeated poles of Hz on the unit circle. In this case, the system is unstable. We will take some example and we will see. So before that, we'll just write this definition like a causal, like a discrete time LTI system to be stable if the ROC includes the unit circle. So coming here, like a causal, let's take an example of a causal system. So we have to find the value of alpha and beta for the system is stable. Find alpha and beta for the above system to be stable. So in this question it is given, so we will just first write the transfer function. So 2 of yz is equal to alpha of z to the power minus 2 yz minus 2 of xz plus beta of z to the power of minus 1 xz. Now we'll separate the yz and xz term. So that will be 2 of minus alpha z to the power minus 2 equal to xz minus 2 plus beta of z inverse. So the transfer function hz is equal to yz by xz. So this is given as beta of z inverse minus 2 divided by 2 minus alpha of z to the power of minus 2. So for the system to be stable, beta can be any value like this. First we'll see here 2 minus alpha z minus 2, that should be greater than 0. So here 2z square minus alpha equal to 0, let's take. Then z is equal to alpha by 2 under root. This should be less than 1. So this means alpha is less than, like root alpha is less than under root 2 here. And beta can take any value because for the system to be stable, all poles should be inside unit circle. So that we have to check. So like the pole here, that is root alpha by root 2, that should be less than 1. So here the magnitude of alpha should be less than 2. So for this question, the answer is magnitude of alpha should be less than 2 for the system to be stable. Now we will take some like what are the poles and other things for transfer function, and accordingly we'll see some examples. Let me check.
Sir, here beta can be any value.
Yes, yes.
Okay. So beta actually defines the zeros, right? Zero. So zeros are not.
No, like if we will simplify this, we will get as beta by z minus 2 divided by 2 minus alpha by z squared. So we will get as beta minus 2z. So this z square will go up. So it will become into z. The only thing is that for this should be like 2 of z square minus alpha. That should be like first we will equate it to 0. So we'll get the value of z. So z is equal to here under root of alpha by 2, and the magnitude of z should be less than 1. So that's why the pole will be inside the unit circle. And after that, the like if let's suppose this alpha by 2 is less than 1, this is the value. So this will contain this z is equal to 1. Here beta does not contribute anything. Like if any value for any value of beta, if root under alpha by 2 is less than 1, the unit circle will come in the ROC. The last question was taught in this lecture. It was up to lecture 20, 29 only. Like in week 6 also, lots of things will be taught for this jet transform. So that time also we'll discuss lots of problem. Before that, I will take today some more problem. Let me check. So we'll take one more question. Like for let's suppose this is a simple we'll discuss. If the transfer function z is given, like let's suppose 1 by 1 minus half of z inverse into 1 plus 1 by 4 of z inverse. Now in this question, let's suppose if it is asked to whether the system is causal or stable, and the ROC for this is given as magnitude of z is greater than half. So for this question, if we have to discuss whether the system is stable and causal, so what we will see, like we can see here, when we to finding the pole here, we can equate both the part as 0. So it will be 1 minus half z inverse equal to 0. So we'll get as z is equal to half. And from here we will get z is equal to minus 4. These two are the pole of this poles of Hz. And this ROC is like outside the outermost pole, as we know. Hence the system is like here, the like outermost pole, the magnitude of Z1, that is half. So let's suppose this is half. So the ROC will be this region. In this question, we will check that whether the Z is equal to 1 circle is lying in the ROC or not. So it is lying, so this system is stable. So we can simply check whether the system is stable or not, just by checking whether the z is equal to 1 circle is lying in the ROC of that signal. So these things we can discuss. And like for today, like this lecture is already so late, so I will close the lecture here only. In next lecture we will discuss some of the question of jet transform, and also the next topic what is taught in the next module. So I missed this lecture on Monday, that's why I'm taking on Sunday due to some other meetings. So today we can close here only. Okay, thank you so much sir, for your time.